Hi everyone, welcome to Cola Teaches Math. Today we're going to talk about separable differential equations, which is one of the topics in AP Calculus. So first thing we're going to do is we're going to separate this differential equation, okay, only using multiplication and division. So if you can do it in your head, great. If not, watch what I'm going to do. I'm first going to essentially cross multiply. I'm going to get dy equals xy squared dx. And your goal is to keep the x's with the dx's and move the y's with the dy's, which would mean I need to move this y squared over to the other side. So I'm going to divide it out on both sides. So when I separate it, this is my separation. I'm going to have dy over y squared equals x dx. Okay, we separated. Now we're going to integrate both sides. The thing is, with the one on the left, that is not ln. ln would only be if it was a y on the bottom, it's y squared. So I'm going to bring up and make it y to the negative 2. And the right side, I'm just going to keep x dx. So we're going to add 1 to the power, divide by the new power. And then the right side, we're going to have x squared over 2 plus c. You only have to add the plus c to the side with the x, because it's a constant, so it doesn't really matter. It's just proper notation usually to add it to the side with the x. So this right here that I'm going to box in blue is called the general solution to the differential equation. So this is the general solution because it still contains the c. So now if I want to find the particular solution, I have to take into account these initial conditions right here. So I'm going to rewrite this differential equation now and make it a little bit easier to work with. So I'm going to write it as negative 1 over y equals x squared over 2 plus c. I'm going to plug those initial conditions in. Y is 2, so negative 1/2 equals x is 1. And I'm going to use this to solve for c. So we're going to get negative 1/2 equals 1/2 plus c. If I take away 1/2 from both sides, we're going to get c to be negative 1. So now we're going to go ahead and we're going to replace this c right here with negative 1. All right, so I'm going to do that right over here. So we're going to have negative 1 over y equals x squared over 2 minus 1. And remember, we want to solve for y. That's the whole thing behind a particular solution. So watch what I'm going to do. I'm going to multiply both sides by y. Right here in black. It's kind of hard to see. My apologies. Because that's going to cross out that y there. And we're going to get negative 1 equals x squared over 2 minus 1 times y. And then I'm going to divide both sides by the parentheses. And we're going to get a final answer. Let's move this down. Of y equals, because those are going to cross out, negative 1 over x squared over 2 minus 1. And if this was multiple choice, you probably would have to simplify it further. Okay? So I'm going to do this next one a little bit quicker. Here we go. Well, they want me to find the particular solution for this differential equation. So this one's actually kind of easier because we're going to have dy. If I cross multiply, we're going to get dy equals sine x plus 1 dx. We're going to integrate both sides. There's technically a 1 here, and we're going to get y equals, the integral sign is negative cosine x, plus x, do not forget to integrate the 1, plus c. And now we're going to use our initial conditions right here to find c. So let's go ahead and do that. We're going to have y equals 1, x is pi over 2, plus c. All right, so that's 1 equals, so the cosine of pi over 2 is going to be 0. So this whole thing is going to drop out. Pi over 2 plus c. And then c is just going to be 1 minus pi over 2, which is totally fine. So now my particular solution is going to be y equals negative cosine x plus 1 minus pi over 2. Done.